All right, welcome everyone. Tonight, I'm going to talk about the awesome and fantastic stuff in the universe and space. Stuff that there's lots to talk about. How big are things, how far, how hot, how cold, how fast, how downright weird stuff is and unbelievable compared to what people normally see on Earth. So there are many types of things in the night sky. So I've collected some short snippets here, some comparisons, analogies that would sort of make it more real and memorable for visitors to our star parties. For instance, a few years back at the DDO, one of the people visiting, the guy said to me, a star party, where do you serve the drinks and the food? I thought, well, maybe he's a little bored or maybe it's just tongue in cheek. So making it exciting for some people is very easy. You know, you get the people who are looking through a telescope for the very first time and they're enthralled by it, or the person who's checking the end of your scope after they're looking at Saturn inside and they're wondering, you know, do you have a toy model there that they're looking at? Hasn't happened to me, but I think it happened to someone in our group. But it's not always that easy. The skies might not cooperate with clouds all over the place or in the places where you've picked a target. And things may look like a fuzzy blob. You give some decent, interesting facts, you think, and some people, they're not impressed. Or maybe you just want to do something and enhance their experience and make it more memorable. So the average person isn't too enthralled by a fuzzy patch unless you tell them something, tell them a little story about it. So you pick a bunch of targets across the sky, some cool facts about them, and there's one fact to remember. If you can't answer a question, the answer is always hydrogen and lots of time. And I like to have some props around cell phones, apps on them, or a tablet, or maybe some graphics and charts, and I'll talk about them, show you some. And a little story or something about it, a little more convincing than what this person is trying to do here. You picked the wrong target, I think. So let's start out. Number one. Some of you have seen this before, but if you take all the planets and line them up between Earth and the Moon, this is all to scale, and the distance between Earth and Moon is to scale. They all fit. So this is like about half of 1% of the solar system mass, with the sun being everything else. And it can be pretty impressive. And of course, you can flip Saturn sideways, and the rings stretch almost from Earth to Moon. So you've got a number of talking points here that you can get into with people, maybe while they're waiting in line to look through the scope. But it's possible that you could get carried away, as I sometimes do, and it's just too much information, at least for some people. So how about this? Here we've got the Moon replaced by one of the gas giants, and this is what it would look like. Wouldn't that be an awesome sight? So while they're waiting to look through the eyepiece at Saturn or Jupiter, you could show this and start talking about the planets, about how Saturn is the least dense planet, and if you threw it in a giant swimming pool, it would float. That always gets people interested. And then you can start talking about other things about Saturn. Or you talk about Jupiter, how giant it is with, 11 Earths lined up in a row is the width of Jupiter. And yet that giant planet spins around in just 10 hours. And it has dozens and dozens, I think 79 moons now, but your poor visitors are only going to see 4 of them in your telescope. So it can start a whole conversation. People can ask questions. And speaking of the moon, we've got our own handout here of the moon. Have people and little kids in the lineup try to pick out the man on the moon and the other things on the moon. And some of the targets you can look at, I often have binoculars that I can hand out, and they can look at the moon while they're waiting to look at, the craters, the craggy surface. It's always handy if you have an app or some sort of map of what they're going to look at on the moon, so that they can identify things and orient it. And I like to use an app called Moon Globe. It's free for iOS. There's Moon Atlas, there's others for iOS. For Android, you've got Lunar Map Lite that's free, Loonscope, Moon Atlas, and there's others. But something like that can show them the different craters, information about them, where the spacecraft have landed on the moon, and set up a bit of a discussion and some interest. And of course, the kids like to move the moon around and expand it and contract it on your tablet, so that's always fun. So switching to the night, from the night sky to the daytime, there's the sun. So Sean here handles solar observing, and well, it can be a bit of a nightmare these days because you bring up the sun. Most of us have white light scopes, so there's a beautiful image of the sun these days. You have a 1 in 3 chance of seeing sunspots. So I sometimes wonder whether these days of a low solar cycle, whether hydrogen alpha scopes and Herschel wedges are really hot sellers these days. They may be. So what I like to do is always have solar eclipse glasses. Now, I'd love to have this for people to try out, but unfortunately I don't know any welders. But I try to pick solar glasses that have that carbon color to it because it gives an orangey color, and people love that, and you get a lot of oohs and ahs, like the pictures from last weekend's solar observing here. And I also have a few props that I bring along. This is not a great picture, but a little ball that represents the sun. And then I pick some beads and a bolt that represent planet Earth and Jupiter. And then I have a contest with the kids and adults to guess which is Earth and to guess which one's Earth. And so far this year, I think it's about 50-50, the guesses. So Earth is bigger than it looks in some people's minds. And you can have a whole dialogue about how big's the sun and information about that started from something like that. Now, here are a few sun facts. I mean, there's a gazillion you can talk about. You can talk about the size stuff. So holding over 1 million Earths, that's pretty amazing. Holding most of the mass of the solar system, or that it takes tens of thousands or hundreds of thousands of years for the light bouncing around inside to get to the surface, and then only a short time to get to our eyes. Or you can talk about the life cycle of the sun. You can talk about how hot it is, a whole variety of things. The only thing is, be careful about too much information. You could get carried away here. So another thing that I have a little Ego box with a DVD in it, in a slit, and it's taped up sort of like this. And for young kids especially who really can't see that well in a telescope, or little older kids who don't want to look, or young kids who don't want to look through it, everyone wants to look for the rainbow in a box. So making this homemade spectroscope, it's very easy, it's a lot of fun, and it gets a decent reaction. Now, flipping to the night side, if you're interested, you can buy a star analyzer 100 or 200 that you can attach to your eyepiece and see the spectra of brighter stars like Vega. And if you spend a little more, you can get software that you can collect data and analyze it. I think Eric talked about that a couple of years back. So the sun, our star, how far apart are things? So the things talk about are how big are things, and try to relate that to something people can understand or fathom, or how far apart are things. So if the sun was the size of a soccer ball, and its nearest star, Proxima Centauri, was the same size as, it's actually probably an eighth of the size, but was a soccer ball too, then they'd be at either side of Canada. That would be the distance between those stars. So that's pretty amazing, the amount of space between stars. And you can use this analogy if you want to talk about, say, the Andromeda galaxy and our galaxy merging in several billion years. The stars won't very likely crash into each other because they're so far apart. You make it more amazing, but a little more complicated if you blow it up to the size of the actual star. But that gets maybe a little too much. This is one of my favorite to talk about if you've got a crowd that, you know, is engaged and is willing to hang on for a bit. This comes from NASA and JPL, the bottom link there, nightsky.jpl.nasa.gov. They have tons and tons of different outreach material that you can search through under their outreach section, and this is one of the really nice ones. It comes with a whole explanation, some handouts, PowerPoint presentations. They do a very, very good job. So the idea here is there's 200 billion plus stars in the Milky Way, and that's a big number, and no one can really fathom how big that is. So this makes it real. So what you do, there's maybe a child in the group that's about 4 foot tall. You say, well, if you stand at the corner of the field, we'll build a fence as tall as you all the way around, and then we'll send all these dump trucks out to all the PetSmart stores across Ontario and buy all this bird seed. And we load it into the center of the field so it piles up as tall as you are. And that would be about 200 billion stars if each of those bird seeds was a star. 200 billion, that's 200 billion. Actually, the bird seed would represent a red supergiant star in the model that we continue with. And we make a model of the Milky Way. So we take all that bird seed and we spread it from coast to coast across the United States. And we spread it the same distance from Mexico into Canada. Over the middle of the United States, around Illinois and Kansas, we spread it a little higher. So over the middle, we're going to go up 80 miles, which I think is 130 kilometers high, to show the bulge in the Milky Way. And everywhere else, we're going up about 40 kilometers or 25 miles high for the thin disk. And then our solar system would be a loony just south of Toronto there in Cincinnati, the middle of Cincinnati, and our sun would be a speck of sand sitting in the middle of that loony. And that would be the Milky Way. So we figured out what 200 billion looks like and what the Milky Way would look like if we modeled it. So I love this example, and sometimes I have people who have the patience to go through it and really like it too. Now, another thing we could model, I talked about Andromeda and our Milky Way colliding. So here's the Milky Way, and it shows that curve that scientists recently discovered. Our sun's there about halfway out from the center. So it's very, very thin, only about 1,000 light years thick and 100,000 light years across. So that's a ratio of what? 100 to 1. So what's like that a CD or DVD is? So one CD or DVD could represent that 100,000 light year Milky Way galaxy. So you hand that to one of the kids in the group, and you hold on to the other one that's the Andromeda galaxy. And you go about 8 feet apart. So with our scale of 100,000 light years, the 8 feet would represent the 2.5 million light years that our two galaxies are currently apart. And then you say, okay, well, walk towards me real slow, like take 4 billion years to walk to me. And that's the actual motion. Mind you, because of their combined velocity, they're approaching each other at something like 300 kilometers a second. Is that right? 300 kilometers a second, yeah. It's quite amazing, and yet we've made this model, we shrunk it down so much it doesn't seem that big at all, but there you are. And another one I was looking for, I eventually found it. I had it before but lost it. The Astronomical League in the US came up with this poster that you can go to the link and print it out. And it's kind of neat because it shows our shows our galaxy up here in the top, and this box here is expanded down below here. The cross here marks our sun, and the circle here around the sun, and you see it there at the top, it's quite small. That circle contains all the stars that we can see naked eye. So there's like, 4,000 light years out. That's how far this circle goes. And virtually all the stars we can see in the night sky, naked eye, are in that small patch of sky. In fact, 1,000 light years out, 90% of the stars we can see are out that far. So it can be a pretty amazing talking point, and to illustrate things about our Milky Way. Now, everyone has probably seen the Hertzsprung-Russell diagram, and we have all these wonderful stars shown here. The big stars here live fast and furious, and they die out in only millions of years or hundreds of millions of years. Whereas the smaller stars down here, they live a very long time, billions of years in comparison. And that's all pretty amazing, but maybe it's getting just a little TMI for some people, and maybe try something like this. Talk about star nurseries, teenagers, and seniors as far as stars go. So star nurseries, well-known ones like Orion Nebula here, in the summer, the Trifid, M17 and Omega, M20. Well-known clouds of gas and dust forming stars actively now. On the right, we have the Pleiades, or Subaru, with its nebulosity from these recently formed stars. And recent isn't like, 10 years ago for humans. For stars, it's millions of years. And down at the bottom, we have the seniors, the old folk of the Milky Way, the globular clusters that are almost as old as the universe, 12 billion years. And there's lots of them in the summer sky to pick from, to show people, and then talk about the different types of stars. Maybe it's a little more interesting than the Hertzsprung Brussels star chart. This is another graphic or chart you can print off from nightskyjpl.nasa. It gives one of the basic cycles for forming, for the life cycle of smaller stars like our sun, and for giant massive stars that result in neutron stars or black holes from a supernova. So if you're showing planetary nebula, like Andy was talking about, this can pull out and you can use that to talk to it a bit more. If you're hunting down the supernova remnant, you could talk about this. If you're showing the black hole, or you're talking about the black hole near the middle wings of Cygnus, the swan, high above us when you're at the DDO, as Cygnus X1 was discovered at the DDO, you could talk about the life cycle here of a black hole. So this is handy in a number of ways, and you can get it white on black, black on black. It has a whole bunch of material explaining it, PowerPoints on black holes and so on. This is one of my favorites, the blinking eye test. I remember once we had a bunch of astrophysicist students coming to the DDO, and I showed them this and did the eye test with them, and they'd never heard of this before, so it's kind of neat. So it looks, like a faint gray patch with maybe a star in the middle. Because of our rods, 100 million plus around our eye, we can only see the dim stuff, and we have very few cones in comparison that only sees the bright stuff. So staring directly at it, maybe about 150 power works well. You can see the bright central star, but then you look with the side of your eye, and it's a challenge for some people, so I have a contest sometimes, and quite often the kids win. The star disappears, so it's called the blinking nebula. So it's a fun thing to do, and the most fun of all the planetaries, I think, although the ring nebula is pretty impressive due to its size. Let's go to supernova. So the right-hand side of that life cycle of stars, the same website has monthly star charts you can download that show what are the stars like Deneb here with the cross there that are likely to go supernova. And it gives a little information about each of them. So each month you can print one of these off. My favorite is actually not on this chart. It's Mu Cephei in Cepheus, which is so easy to find using the pointer stars to Polaris and keep going through, or between this star and Polaris, it's right in the middle. Easy to Whoa, wrong discussion. It points you to Cepheus, but then Musaphite is down here. So it's very a nice star to look at, very red. If it were at the center of the solar system, it's so large it would go between Jupiter and Saturn, extend that far out. It's fusing iron now, so any time it could go to supernova. Any time in stellar terms is thousands, millions of years. But since it's 2,800 light years away, we don't know if it's done it already. And then another slide is what are some of the elements you can get on the right hand. I think this is dying on me, my pointer. On the right hand side, some of the elements you can get only from supernova, or mainly from supernova. And down below, things that those elements provide us with our lives, our daily lives. Calcium in our bones, or silicon for our electronics. Where would we be without supernova? So the classic line, we're all made of stardust. And lots of people show the double-double. It looks pretty neat with the two stars, two pairs of double stars close together. And you can find lots of interesting facts about epsilon 1 and 2. They're all about the same brightness. They're very close together. Their orbits are in terms of hundreds of years around each other. But wouldn't it be more fun, since it's the double-double, we call it the Canadian Connection, Tim Horton's double-double. So it's more of a fun story down below, if you call it Tim Horton's double. And an interesting thing I found on Sky Safari in the notes there was that if you're in a spaceship at one of the pairs, looking at the other pair, they would be about twice the width of the full moon and as bright as the quarter moon. And then you can mention about the pairs circling around each other in hundreds of years and the two pairs going around in hundreds of thousands of years. Just a little something to add to looking to the double-double. Now, Astro-Doodles. I don't know what it is about astronomers, but over the years we've come up with constellations and we have the line diagrams, but I mean, Pegasus, yeah, it sort of looks like a horse if you have the lines drawn out, but honestly, these 4 stars in Aries, how does that look like a ram? So I call astronomers Imagineers. But we do have things that do look like what they are. The Big Dipper is the obvious one at the top that we'll all talk to, but there's lots of others. The coat hanger is a favorite. I usually have a pair of binoculars, or I like to have a pair of binoculars that I put on a tripod and point at it, or show people how to find it, and then they try to find it with the binoculars and they get pretty excited when they do see it. There's a hockey stick, a lucky 7, Napoleon's hat here next to Arcturus. Might need a bigger aperture scope so that, and put Arcturus out to the side so that you could see it better. There's a golf putter and a backwards 5, and there's others. And these asterisms, they look like what we say they are. So often the question of, do you believe in life and other planets? Sure I do. I bring up the ET cluster or the OWL cluster in near Cassiopeia. And we could show that, but here's something again from NASA that's useful and interesting. They have monthly charts, and on the charts they show stars, brighter stars, that have planets. And one I like was the one I mistakenly went to before that's easy to find with the pointer stars pointing through Polaris and right to Gamma Cephei, one of the brightest stars with planets, binary I believe. Initially, it was 3 Canadians in BC that, using radial techniques, I think, thought that it had a planet, but it wasn't really thoroughly proven until 2002. But this could be something you talk to people. Maybe not all the stars you want to show are, or maybe it's not a great night to look at faint fuzzies. Maybe you're looking at stars. Here's something you might consider doing. And what if it's hazy or cloudy, speaking of that? So I have a few bright stars that I like for the summer. Arcturus, it's a fast-moving star, and it's kind of interesting that it opened the Chicago World's Fair with its light using the light that left the star the previous Chicago World's Fair. How that came to be and someone thought of that, I don't know, but that's kind of interesting. My favorite is Vega. Vega is spinning almost at breakout speed, and it bulges about a quarter in the middle. It's spinning so fast. Our sun goes around in over 20 days, 26 days or so, but it goes around in 12 hours. So it's almost at its breakup speed. That I find a little interesting. Or if you're in the later fall, winter, Betelgeuse, one of the brightest stars. It's pretty far away. Red supergiant could go supernova, and it may have already. It's the first disk to be imaged, so you could have a picture on your tablet showing the image of Betelgeuse. And finally, I come to my number 10 plus, or 17 to you. What would it be like to be inside a star cluster? What would that look like? Can you imagine that? I came across this story by Isaac Asimov, Nightfall, and there's a planet, Calgash, that in the story has 6 stars that it's orbiting around. Now, that's not a stable system, but this is what Asimov have proved. But astronomers haven't come up with a stable system. But the idea was that every 2,049 years, the stars would line up so that 5 of them were all lined up, and presumably on one side of the planet. And the sole moon that was in the sky that you couldn't see because it was light all the time would eclipse the other sun, and you'd have about 15 minutes of darkness. And generations of people living just with sunlight all the time were terrified and went crazy and so on. Interesting story. So what would it be like? And by the way, this Calgash lived in a star cluster with 30,000 stars in the night sky, which only happened 15 minutes every 2,000 years. 30,000. We have 9,000 from 6.5 magnitude down. Say we see half of them in one hemisphere and half of them at the nighttime, so we're talking 2,500 stars versus 30,000. Big difference. So what might it look like? A few years back in Astronomy magazine, astronomer did an analysis of 47 Tuc, a beautiful globular in the southern hemisphere. About 500,000 stars, sort of like the Hercules cluster, M13. So it probably holds if you're showing M13. So if you were in a spaceship, or if Earth were transported to the center of M13, the night sky would be so bright, 20 times brighter than the full moon. There'd be over 130,000 stars in the night sky versus the 6,000 you would see. The brightest stars, there'd be 10,000 brighter than first magnitude, and we only have 29. It's just amazing. So this is intended to depict what the night sky might look like to naked eye inside a star cluster. So that's an interesting story, and it might get people talking, get people engaged. I hope you liked my 10 examples. There's lots of great material in the top reference there, and I've mentioned some of them. And there are all these other references you might consider going to. And just want to thank you all. There's many more interesting facts and stories. I'm always looking for some myself, and I hope you do too. So thank you again. And does anyone want to raise some questions? Or Ed? I had to pick the one furthest away. I like to give Paul a workout.
Certainly. I'm wondering, having done outreach, and sometimes your mind kind of freezes up and questions come. Yeah. How do you queue up all these things? How do you have them at hand? Do you have like computer? How do you know all this right off the top when someone asks you?
I have a computer here. How do I know? I've gone through some of these over time, and before the star party or whatever, I have some idea of things I might look at, so I just refresh my memory on those, or I dig up some more dirt on some things if I don't have anything, like the Vega thing or Arcturus. And I make a few notes on a little piece of paper. I still use paper a lot. And I wing it. I mean, if you don't know the answer, you always say you don't know it, or I'll look it up, or, why don't you look over there, and I'll look it up and come on back in a few minutes. I can always say hydrogen plus time. Over here, Andy.
I've used the Tim Horton's double-double story before. You can elaborate on that by popping over to M57 to show them the donut that comes with it.
Oh, I like that. Excellent. Excellent. Anyone else? Okay. Well, thanks very much.